Hi, this is a quick video review of SplitBeam's Meniscope 721/20 quick torque wrench. It has a half-inch drive and a torque rating between 40 to 200 Newton meters, which equals 30 to 150 foot-pounds. It is a derivative of SplitBeam's 730/20 torque wrench, with the difference being that the 730/20 has a, I would say, it's a replaceable head. So that torque wrench only comes until roughly this point where it has a tool carrier, and you can insert different heads into this tool carrier, so that would afford the user with some a lot of extra flexibilities, but in my opinion not necessarily that useful. Those possibilities include, for example, reversing the direction of the insertion tool, so that you can use this torque wrench also for counterclockwise operation, because it is, as you can see here, it has a single direction only, because this is a split beam torque wrench. It has only a single direction of operation. So with that replaceable head, you can basically invert the heads, install it in the opposite direction, and then use it for counterclockwise operation. I don't find that quite useful, because most areas where you need to torque actually are the standard clockwise tightening, basically standard thread, so not reverse thread. So I find that to be not so useful. And another difference, of course, another benefit with that replaceable head in the Meniscope 730 is the ability to use other types of insertion tools, such as not necessarily a ratchet, but also a crawl foot, and other type of a box end. And I think there is even an option to make your own tools. So there is this, I think SplitBeam sells this bit that actually just inserts into the tool carrier, and then there is this point with a little bit extra metal that you can solder on whatever that you want. I really don't find that useful. And this 721/20 quick being slightly cheaper, I would say by 10%, I find that this probably is a good place to save a little bit of money and avoid unnecessary complexities, because this one, this head actually, and this head, and I would say up here, up to this point, the mechanism is a single piece. So we have one fewer part to fail, and it is slightly more robust, in my opinion. This is the reason why I chose this. Now let's talk a little bit about the packaging first. Packaging obviously is very austere, as usual with these German torque wrenches. So basically everything came with this plastic tube that is not really a tool carrier, it's not a toolbox. What they want to do is to sell you a toolbox. SplitBeam wants to sell you a toolbox. What's worse is that that toolbox doesn't have an insertion, so no foam, no plastic inside. It's just a box. And they also sell a plastic that has the forms of a range of their torque wrenches blown into it, and you can then purchase that plastic, put it in that box. I find that to be really not laudable. I think that they should include a box. I don't think that box is going to be that expensive. But of course, Germans being German, they are very good at cutting costs. So that's where they cut costs. Now you get this sheet of information, although they are showing the Metascope 730 quick, not the 721. As you can see, actually here, you can see the 730 really here it has a tool carrier, whereas this one doesn't have a tool carrier. So I think the smaller one, which is a newer version, in fact, that one has sizes 2 and 4, which range to 20 Newton meters and 40 Newton meters respectively. And the larger ones, they have sizes 5 all the way to, I don't know, 40 or 50 or maybe even 60. And 5 means the upper limit is 50 Newton meters. Like this one, 20 means it's 200 Newton meters. And 40, of course, means that it's the upper limit is 400 Newton meters. You can see here it shows the information here. Some information here, not very useful. And here this shows how you can adjust the torque range. You can see here it tells you to reverse the insertion tool in order to have a counterclockwise operation. But of course, for this fixed head, it doesn't work. Inside the box, there is also a calibration certificate. So it's only rated for 4%, but this particular one is within 3%. Still not that great, but anyways. So let me show you now how to operate, how to adjust. The torque range now is set, I don't know if it can be seen, let's zoom in a little bit. So now the torque range is set at, let me just open up the aperture a little bit, so maybe it will be better. Let's open up a little bit aperture, yeah. So here it's set at 200 Newton meters, which is the end. So what you do is, if you see at this end, try to go this side. As you can see here, there is this lever. You use one thumb to press on this lever, and then you can adjust the scale. So for example, let's say we want to go to 120. Well, what we should do is just slide it. Let me see. Slide it. Yeah. So now it's roughly 120. I think a little bit below, but anyways, below 120. Right. So if we want to go to 40 Newton meters, what we do is we now move it. Let me see. Okay. So now it's at 40 Newton meters. One thing that I don't really like is the fact that this lever is actually very, very heavy. I don't think people who are a little bit weak will find this very enjoyable to use. For me, it's just barely workable, and I think I can. This grip exercises, I can do 60 kilos without any problem for hundreds of reps. But this is quite heavy, I have to say. But this is basically how this torque wrench operates. With this specific one, it's a 721/20 quick. So let me close down the aperture a little bit. Yeah. Actually, open up. This one has basically a ratcheting head that's fixed. Now they also sell one that is, I think, called 721/20 20QR, that one would have a quick release function. I think it's basically essentially the outer part, the casting is I think it's forged, but anyway, the head is otherwise the same. The only difference is the anvil. That one has a green little button, but it has the same tooth count, which is 36. I think it's 36 teeth. So let's see. So now we are facing to the right. We can count this 1, 2, 3, 4, 3. I think 4, 5, 6, 7, 8. But anyway, so I probably miscounted. I think it's 36 teeth. So that's basically that. Of course, it's a reversible ratchet. This one being a split beam design, so what it does is I think this head to this part is a solid part, and this triggers something, I would say, in the mechanism around this part. It's basically a trigger. And this trigger is connected to a beam, essentially a metal beam that is around this part. And this slider basically adjusts where that beam is being clutched, and that's basically helps it adjust the tightness of this trigger. And when you have torqued to a certain preset torque, this trigger will actually will open. And you will hear a single click. I find this is quite unlike other torque wrenches. Most other torque wrenches that I've heard, that I've seen, that I've used, have double clicks. This one I think has a single click. I don't know exactly why. It's quite loud, so you will hear a very loud single click, and it will stop. So that's how this mechanism works, right? Essentially, I think on Stahlwille's website they have a very interesting blog post. In that blog post, they discussed a range of torque mechanisms that can be found in torque wrenches. They listed 5 for this click type torque wrenches. The number 1 is slipper clutch, which we all know it's basically a ball bearing on a detent that's being propped up by a spring. That slipper clutch will slip once the preset torque is reached. And that is, Stahlwille says that they only use that today in torque screwdrivers because it's not so great in high torque applications. Supposedly that the reason is that once the torque setting is reached, you can actually injure yourself quite easily if it's a high torque application, because you completely lose any control. So that can lead to some injuries, which is why in high torque applications slipper clutch is no longer used. They also talked about a couple of other mechanisms. One is a triggering cam, and that one is, I think, found in most of the commercial torque wrenches that we can find today on the market, especially the cheap ones. That one has a spring, and it also has a very similar trigger mechanism. The difference being that the trigger is being propped up by a spring that you can adjust. When you adjust for higher tension, the spring gets you will see that the handle usually comes in, and the spring will be compressed and the trigger becomes tighter, and that's basically how a triggering cam works. In my judgment, the split beam design that Stahlwille uses is really replacing that spring with a steel rod. The benefit of this, and there are some other changes, mostly to release the tension on that steel rod. So when you are not torquing, and when the preset torque has reached, the rod does not have any tension. In that sense, this Stahlwille's design is a triggering cam without a constant load on the spring, so that it really doesn't need a lot of very frequent calibration. It doesn't lose calibration, and as that steel rod is only under tension when when the wrench is being torqued, it's not really going to wear out very easily. And also, of course, a steel beam also has naturally a better retention of its tensile characteristics than a spring, which almost always naturally weakens over time. So that's basically triggering cam. And another type of mechanism that has been mentioned in that torque wrench is tilt block. That one is a little bit similar to triggering cam, except that there is no longer a trigger. A trigger is being replaced by a cubic, not really cube, but a small block, metal or synthetic. And when you torque the torque wrench, the upper part would tend to, that's connected to the head, would tend to tilt to a direction. And when this tilt is enough, this force is enough, it's going to tilt that block to the side, and that is how you get a click, and that signals that you have reached the preset torque. The benefits of tilt blocks, in my judgment, is that it allows for counterclockwise operation. So if you buy a micrometer type, meaning that there is a spring inside, a micrometer type torque wrench, if the torque wrench can only work clockwise, it's probably a triggering cam torque wrench, which is more affordable. It should be cheaper. If it can be operated also in counterclockwise direction, it almost certainly is using a tilt block mechanism. This split beam design by Stahlwille, being a variation, in my judgment, of triggering cam, it can only work in a single direction, which is clockwise. Which is perhaps also why Stahlwille wants to sell you this one with a tool carrier, like this 730 is the standard one. With a tool carrier. This way you can have reverse operation. Last thing I wanted to say is that there are some, I would say, misinformation on the internet with regards to the evolution of Stahlwille's torque wrenches. I think some people are saying that the 730 is an old design, whereas the 730N is a newer design, and it's partly true, because Stahlwille sells monoscope 730, sold actually 730 without the quick. That one has a black handle. I think it can still be found on some places. It has a black handle, and I think this adjuster has a red dot. That one is the old design. And then Stahlwille introduced the 730N, and that one has at the back of the handle something that you can twist instead of this quick slider design. That one is a newer one, but the latest one is actually the 730 Quick, which is essentially a 730 with some supposed improvements. I'm not sure where those improvements are, because I think this is purely mechanical. Perhaps it's mostly in the grip and in the branding, using this green rather than red, which is the Stahlwille green. I don't know what else where else the improvements could be found. But anyways, this is this is actually a newer design. And the latest one is this smaller one, which are only for even smaller sizes. That's /2 and /4, as I mentioned before. Alright, so this is my review of Stahlwille's Monoscope 721/20 quick torque wrench. Thanks for watching. Have a great day.